Hey class, this is Mr. Chang. This is lesson 2.2, video 1. In this video, I'm just going to give you a preview of the whole lesson, a little motivation, and also a little introduction to the concept of the limits involving infinity, whether that is the limits that approaches infinity or limits that ends up as infinity. If you need to skip ahead, feel free to do so. Each video will have a title along with some description of the video, so you could skip ahead. So please feel free to do so. Here's a little preview. Okay, so take a look at this lesson note right here. Take a look at the first graph. Can I describe this situation? Can I describe this graph, this function, with the limit notation? Okay. Last lesson we talked about the left limit and the right limits. For this particular graph, one notation that I could write is the limit of f of x as the x approaches a from the left side. And that appears to be, let's take a look at that. From the left side, you're approaching positive infinity for the y value. And the likewise is true for the right side. Okay, the limit of this function, the first graph that you have on this lesson notes, if you this time take a look at the limit, take a look at the function from the right side approaching at the value of x equals a, your y value will increase without any stop. Okay, your y value, so limits of f of x as x approaches a from the right side, you could say that it's going to be positive infinity. And if you look at the second one, the opposite is true. Okay, so limit of f of x as the x approaches a from the left side, this time your y values are descending. Okay, as you get closer and closer to the value of x equals a, you're getting closer, you're getting really close to that vertical asymptote. Okay, while your y value is decreasing very rapidly, we could say that our limit is negative infinity from the either side. And for both of these examples, as a result, you could also conclude that the limits at f of x as the x value approaches a is equal to positive infinity. And because the left limit and the right limit coincided for the second example as well, so you could combine those two statements and say that the limit of f of x as x approaches a is, oh, I made a mistake there. That should be negative infinity right there. Negative infinity. Okay. For the third example, for the third diagram, we could only conclude about the left limits. Nothing that we could do about the right limit. So for this one, we could say that the limit of f of x as x approaches a from the left side is equal to positive infinity. And for this one, we could say that the limit of the function f of x, but then this time x is approaching a from the right side. And because your graph is increasing as you get closer and closer to a from the right side, we could say that the limit is positive infinity. Okay, not a, okay, infinity is an abstract concept, it's not a number value, okay, but you're just describing the pattern of each function with these notations. Okay, you could stop the video and try, okay, to write appropriate limit notations for the function, okay, described with this graph right here. And then here are the answers that I will give you. So as the limit approaches 0 from the left side, you'll see that the y values are decreasing. But from the right side, okay, you could conclude that the limit is positive infinity. And for this question, you could also conclude something about the limit as x increases to a large value. We'll use positive infinity symbol for this one. And then you'll see that, let's see, as the x value is getting larger and larger, you can see that your y value is getting closer and closer to the x-axis. So you can say that the limit of f of x as x approaches infinity is 0, and likewise is true for x approaching negative infinity.